rupees 7,500 were divided equally amongst a certain number of children. Had there been 20 less children, each would have received rupees 100 more. Find the original number of children. Right. So we want to find the original number of children, and I can start the question by saying, let the original yeah number of children original number of children, I'll take that as x. So I can say that the original number of children be x, right? And now we are dividing 7,500 amongst each of these kids, right? And why we try, and so each child will receive 7,500 amounts upon x. And why do I need to find that value? Because if you read the entire question, right? So 7,500 was divided amongst x children. Had there been 20 less, each child would have received rupees 100 more. So we are talking about how much each child is receiving, right? We are talking about how much each child is receiving, and around that value is around that parameter is what I'm going to frame my quadratic equation, right? So let the original number of children be x. So therefore, amount each child receives, let's talk about it as the original amount each child receives. Original amount each child receives will be equal to rupees 7,500 is the total amount that we have, and we are dividing that amongst x children. So 7,500 upon x. That's how much each child will receive. Right. This is the original case. Now in the new situation we had 20 less children, right? So I can say new number of children. New number of children. Right. New number of children is x minus 20. You have 20 less children, and each would have received rupees 100 more. So we are again talking about how much each child will receive. The total amount is still 7,500. So therefore, the new amount each child receives will be, so the total is still 7,500. So now each child will receive 7,500 divided by the number of children, which is x minus 20, right? So in the original condition, each child was receiving 7,500 upon x. In the new condition, each child is receiving 7,500 upon x minus 20, and they've given us a relation between these two values. That is that in the new situation, each child receives rupees 100 more, right? So if I had to write that down as a statement, what they mean by that is that the new amount each child receives right, is equal to rupees 100 more than the original amount. The original amount each child received. Right? We told you in the question it's a rupees 100 more. Okay, so that is the thing in words. Now I got to represent it in the form of an equation. So new amount each child is receiving, we know, is 7,500 divided by x minus 20, and rupees 100 more. Now rupees 100 more means you will be adding the value. So rupees 100 more means it's a plus 100 to which the original amount being 7,500 upon x, 7,500 upon x. So as you see, we are getting our equation now. Let's just rearrange the terms. Let's bring all the like the fractional x terms together on one side of the equation. May make our sums a little easier to solve. So if I do that, I have 7,500 divided by x minus 20 minus 7,500 divided by x equal to 100. Right. Let's simplify this a little. To solve that, what we can do is we can cross multiply. We can take the LCM to solve this. So 7,500 cross multiplication into x minus 7,500 into x minus 20, the entire thing divided by x into x minus 20 is equal to 100, right? So we would like everything to be in the so let's just expand this a little more over here. So in the numerator, so therefore I have 7,500x minus 7,500x, minus into minus will make it plus. 75 into 2 is 150, and I have followed by 3 zeros, so that's 150,000, a very large number. Entire thing divided by, if I expand over here, I get in the denominator, I get x square minus 20x, all of this equal to 100. All right. So let's you notice now we have 7,500x minus 7,500x. Those two terms get cancelled. Let's take this entire denominator from the left hand side to the right hand side. Okay. So therefore I have, and let's bring this 100 from the left to the right as well. From the right to the left, sorry. Yeah, let's bring the 100 from the right to the left. So I'll end up with 1,500, or rather 150,000 divided by 100 equal to x square minus 20x. So two zeros here get cancelled with the two zeros in the numerator. So I have 1,500 is equal to x square minus 20x. Let's write it down in the form of a standard quadratic equation, the general form, so that we can split the middle term and get our final answer, right? So I can say, if I write this in the standard form, it becomes x square minus 20x, 1,500 here, it's plus, take it to the other side, becomes minus 1,500 is equal to 0. This is my quadratic equation in the standard form, which I will solve by splitting the middle term. The product of the factors is 1 into minus 1,500, so that's negative 1,500. Two numbers multiplied should give me negative 1,500, and their sum should be equal to negative 20, right? So two numbers multiplied should give me negative 1,500, and the sum should be negative 20. Those two numbers will be minus 50, right, into 30, right? So minus 50 into 30 is 1,500, and minus 50 plus 30 is negative 20. So those will be my two factors. So that's the way I'm going to split the middle term here. So x square minus 50x plus 30x minus 1,500 is equal to 0. So this is how I'm splitting the middle term here. All right. Now what we can do is we'll factorize this equation. So in the between the first two terms, you can see there's x common. I'll be left with x minus 50 in the bracket, right? And in the third and the fourth term, there's a plus 30 which is common, and I'll be left with x minus 50 in the bracket once again. And all of this business here that I get is equal to 0. Okay, so moving on. Therefore, I can say, see x minus 50 here, both of them. So x minus 50 is common, and in the other bracket, I'll be left with x plus 30. And all of this again is equal to 0. So once again, it's the time for our zero product law, or zero product rule. Product of two terms is equal to 0. So either the first one is equal to 0. So therefore x minus 50 is equal to 0, or I can say x plus 30 is equal to 0. X plus 30 is equal to 0. Now, if I am to solve the first equation, x minus 50 is equal to 0, I get the value of x as 50, or I can say by solving the second equation, the value of x is negative 30. Right. Let's just quickly check back and see what exactly does x represent, so that we know if both the answers are valid or not. The original number of children is x. So the number of children now, remember, cannot be negative. I cannot have negative minus 30 or negative 30 children. So this value here has to be rejected. Now, since number of children cannot be negative, cannot be negative, x is equal to minus 30, right, is rejected. And this gives me the value, the final value for x, right? So therefore x, let's use, is equal to 50. And we'll write a final answer statement now. Therefore, the question was, let's try to frame it just as a question. Find the original number of children, right? So the original number of children is 50, or I can say originally there were 50 children. Originally there were 50 children, and the original number of children is 50. This is my final answer, which I will put in my final answer rectangle.